All right, everybody, welcome to the Daily Space Weather. Lots of stuff to get to today. We're going to blast through a lot of information, so if the pace is fast, pardon that. We'll be talking about geomagnetic storm conditions once again. Also, sunspots 2806 and 2807. 2806 being featured a few days ago on the channel. Before it became a sunspot, it's all about forecasting, baby. Here is the local yellow dwarf over the past 24 hours in 3 wavelengths. 211, 193, and 171 angstroms. And we've got sunspot 2806 right here, sunspot 2807 right here. We saw a C-class flare right around midnight. Geomagnetic storm conditions continue as a result of protonic induction from that coronal hole right there. Protons striking the geospace. More on that later in the video. Here is the solar intensitygram for the past 24 hours, and you can see those sunspots forming there. The C-class flares appeared to have come out of this group right here, sunspot 2807, and there is a potential for more flares and more coronal mass ejections, as there's not only plasma suspended between the sun and the earth, but those are both beta-class sunspots. So beta-class sunspots have 2 different polarities. Allow me to briefly explain. This is a South Pole umbra, and this is a North Pole umbra. Same with this, South Pole, North Pole. And sunspot groups with opposite polarity umbrae are more likely to produce solar flares, so X-rays, than single polarity sunspots. So now we're looking at Lagrange point 5, Lagrangian point 5, the gravitational point of equilibrium at which stereo A is located. And this gives us one of the best views of coronal mass ejections, and indeed we see some. From stereo A's perspective, the Earth would be off to the right, so this is not an Earth-facing coronal mass ejection, but great view of that opposite side of the planet. Opposite side of the sun, rather, coronal mass ejection, right over there. It's a decent-sized one. And let's move on to some helioviewer movies. Here's a 24-hour video in 304 angstroms, so ionized helium is what we're looking at now. And you'll see a C-class flare kick off right at midnight. So right there, you can see that C-class flare. And we've got some better views of that. It should be a little brighter in 171 angstroms, one of the ionized emission spectral states of iron. So here it is in 171 angstroms. Fantastic view of the growth of that new sunspot. 2807 is a little bit larger than 2806. And here are the magnetic fields. So you'll see the magnetic field growth here, and you can see that there are 2 opposite polarity umbrae there. The black would be South Pole, and the white would be North Pole. So the overall magnetic region of sunspot 2806 takes up more space on the Earth-facing solar disk, but the umbrae are larger in 2807, which is the one to the left. And let's get to lots more data to help orient our viewers, and thanks to our new viewers, etc. Thanks to our new viewers, old viewers, loyalists, friends, foes, and neutrals. Here's what's going on in the solar system. It's a diagram of the planets, as well as the moon. Here's where stuff is now on the 3rd, 3/3/2021. And there's where things will be on 3/10, March 10th, 2021. 7 days from now, approaching another new moon. It's a crescent waning. If you're up before dawn and you have clear skies, you may see Saturn rising ahead of the sun. I use in-the-sky.org for star charts. Just put in your location if you want to make a star chart. Where were you in Cygnus Rose? Well, it's been going around and around Polaris for a long time. Let's talk about the radio flux. The radio output of the upper chromosphere and lower corona. The 10.7 centimeter radio flux now at 75. No surprise there, we see 2 sunspot groups. There's the 1-year chart of the radio flux to put it into context. The red line is the sunspot number, and this black line here up top, that's the radio flux. Yes, the sun always outputting radio. And I've just pressed something I totally did not want to press. There we go. And for you new viewers, here is the radio flux through the last solar cycle. And you can see how proportional that is to sunspot number. Here's the NOAA forecast, and we are in currently geomagnetic storm conditions for the last approximately 9 hours. It's a G1 geomagnetic storm, a KP of 5. So, yeah, wasn't really forecasted this way, and we're seeing multiple pulses from the coronal hole wind stream. It came from a South Pole-oriented coronal hole in the south of the sun. We'll show you that later in the video. Next, let's see what's erupting on Earth. It's the volcanoes section, and we're on volcanodiscovery.com. It's where I like to check out what volcanoes are erupting, and thanks for leaving a comment, Kathy Garden. Good morning to you, too. So Mount Etna has been quiet mostly for the past 24 hours following the last paroxysm, which would be a lava fountaining episode. Eyes on Sicily, as Etna has been pretty active. Also, Mount Abico on Paramushir Island is producing a 7,000-foot ash plume. Suwanosejima in the Ryukyu Islands has exploded. Unknown volcanic ash cloud. Please don't do a square dance around the caldera. And thanks to the viewer, you get a writing credit. Cinnabung still producing a 40,000-foot ash plume. So that's the most active volcano on Earth right now. Mount Cinnabung on the Isle of Sumatra in Indonesia, exploding. It's producing a 40,000-foot plume of volcanic ash. Please don't pole vault the caldera. Popocatépetl mildly exploding down in Mexico, producing sporadic emissions of volcanic ash. Please don't fly your home-built kit aircraft over that. Fuego in Guatemala is exploding. Sporadic emissions of ash there. No report on the size of the volcanic ash plume. Please do not do the electric slide around the caldera in Guatemala. Sangay, volcanic ash not observed. It could be erupting. Don't build a campsite on the lower slopes of that. And Sabancaya in Peru is producing intermittent emissions. The largest volcano in the world is a volcano known as Mauna Loa. Basically, the entire big island of Hawaii is a giant volcano, Mauna Loa, and we've seen an earthquake at about 4,500 feet of altitude, actually more like 5,000 feet of altitude, directly underneath the main caldera of Mauna Loa. So this quake here was only a 2.5 magnitude. It's certainly magmatic in nature. It happened at a depth of negative 1.7 kilometers, otherwise known as 1,700 meters above sea level. And that one happened at 13:34 yesterday afternoon Universal Time, so about 1:30 p.m. Greenwich Mean Time. We see some deep quakes kicking off like this 4.4 at Fiji. That was at 542 kilometers depth. And let me just check the life of the stream before we go on, as we are streaming live in order to make this video. So no major quakes, but a small uptick there around the western Pacific Rim. Largest quakes were just in the 5 magnitude range, it looks like. And I'm just going to scroll up the list. Largest was nearly a 6 magnitude there, a 5.8 in Shikotan, Russia. So that one's actually, looks like it's south of the Kamchatka Peninsula there. And due east from Sapporo there. Really closer to Japan than it is to most of Russia. So some deep quakes such as this 4.7 in Indonesia and this 4.5 in Japan. Another deep quake there, that one at 402 kilometers depth, a 4.6 magnitude near Alo Wallace and Futuna. And by the way, for you new viewers out there, this is the deep quake capital of the world. We see more deep quakes and deeper quakes right in that area north of New Zealand than any place in the world. A deep 4.5 struck Alaska. Check it out. That one's at just under 100 kilometers depth, a 4.5 magnitude quake. Hey, Brett, leave us a comment if you felt that one. Here's a 4.6 at Columbia. That one's a 4.6 magnitude tremor at 147 kilometers depth. Here's another deep quake near Fiji, 552 kilometers. So it's a significant deep and shallow quake event. It's an earthquake uptick, folks. Even though we don't see any major quakes, if you're in an earthquake-prone zone, please have a plan, have a bug-out bag, know what will happen, know which buildings may collapse if you decide to evacuate yours. If there's some ancient building facade that you're going to walk underneath as you walk out of a building during an earthquake, be aware of that. And don't get stuck under falling debris if you can help it, obviously. So this Smash stream was streamed live at twitch.tv/smAsho. It's a fantastic mobile platform. If it's good enough for gamers, well, I am a gamer. It's good enough for me. Thanks to all of our followers over there at Twitch, and thanks to our followers at YouTube. We have the most content at YouTube. Check out our playlists, youtube.com/smashamash/playlists for that. And please don't forget to press like and subscribe if you enjoy the content. Press the notification bell and share with your friends and foes on social media. We're also on BitChute. There's exclusive content there as well. And let's do a cosmology segment. This one will be only integrated into the Daily Space Weather video. Check out our playlist there too. We've got cosmology segments in the playlists. Today's cosmology segment, we'll talk about assisting mankind by advancing the study of predictive phenomena. So what are we talking about, folks? We're talking about the fact that, well, you're in space right now. The planet's in space. Yes, I know. The surface of the Earth isn't technically in space, but Earth's in space. And number 6 of our mission, you can read the rest of our mission at smashamash.com/forum/mission, is to advance the study of predictive phenomenon and assist mankind therein in order to optimize value, reduce risk and liability, save lives and resources, and adapt no matter what the adversity is. Your ancestors survived much worse disasters than whatever you're looking at right now. You probably will too. Again, our mission can be found at smashamash.com/forum/mission. You can also find our links to our social media sites and so on at our homepage, smashamash.com, as well as links to our shops. Today's featured product will be Smasher Price My First Pandemic, an homage to the pathetic and infantile response mankind has had to the coronavirus, COVID-19, whatever you're calling it today. Perhaps check out one of these shirts. Smasher Price My First Pandemic, as people attempt to mask the entire planet. Are you safe yet? Again, you can find links to all of our products at the homepage at smashamash.com. We're also on Twitter. Follow us there. Let's pick a random object here between 1 and 1031, which will coincide with an object at the Neil Gorell Swift-Bat X-ray Observatory. Today's is 561, but first, we're going to talk about an update on Cygnus X3, one of the only known cosmic ray point sources. Cygnus X3, which coincides with the star Deneb, which is also the celestial pole star at the other end of the precessional Earth's axial tilt-wobble cycle, about 12,000 years from now, has moved into a slightly more quiescent state here. So you can see it's dropped down a little bit after seeing some of the most powerful transients that we ever see from Deneb just about a week ago. So there you can see those really powerful transients from Deneb. These are X-rays, and these get monitored. Let's go to the random object, which again is number 561. There are 1031 objects on the Neil Gorell Swift-Bat X-ray Observatory. 561 coincides with an object known as AXJ1631.9-4752, which is a high-mass X-ray binary / neutron star. Let's give you a quick look at the transient outbursts from that. And this looks like one we may have actually covered before, but in any case, there are the X-ray outputs from that. And look at this extreme X-ray output there in 2019. Usually it's a lot more consistent than that, but there was a major outburst from this particular object. AXJ1631.9-4752, a catchy name for this high-mass X-ray binary / quote, neutron star, end quote. I'll call it a massive radio source. And let's look at it on Sinbad. We don't want to commit any cosmology blasphemy on the channel. And so I watch what I'm saying, and I try not to say ridiculous, nonsensical things about cosmology, like oh so many YouTube channels do. So here is this object, this high-mass X-ray binary / neutron star in infrared light, and it looks like you are able to see both objects here. These things typically consist of a white dwarf, which is this here, being orbited by a more massive object, which is this, the quote, neutron star, end quote. In any case, whatever it is a massive radio source. And that's why you see this very, very hot star being orbited by this radio source, and that's why the crosshairs are where they are located. Let's see if this shows up invisible. I don't think it does. It doesn't show up in optical light. There's the area nearby. And let's see if it shows up on the XMM. There it is on the multi-mirror project, the XMM multi-mirror X-ray scope. And here it is on Chandra. You can see a pretty diffuse X-ray output from that object. J1633.0-4746E. That's today's cosmic object. And let's talk about much larger scale objects. Those were inside the Milky Way galaxy. This is a galactic cluster. And this phys.org article is talking about radio jets. And you can see a massive radio jet right here coming out of that galaxy. You can see a massive radio jet coming out of this galaxy here. And radio jets are super interesting in that it is one of the ways that galaxies interact with each other. Close galaxies are most likely able to transmit material, namely in the form of material similar to what we see in the solar wind. So mostly hydrogen nuclei, protons at very high, nearly light speeds. And this happens when the galaxy's magnetic fields align with the galactic output. So we know now that this is why when we see these radio jets, they look like train cars. If you want to read the article, it's on phys.org. Phys.org in the Astronomy and Space section talking about Galaxy Cluster CLJ1449 plus 0856. And that's today's cosmology segment. Moving on to more stuff, since there is more than enough stuff to cover, in fact, too much, which is why we expected to be full-time long ago. Anyway, there's the C-class solar flare that happened right at midnight. So another C-class flare kicking off there, as well as some B-class flares following it. That's the GOES X-ray flux as measured by the GOES 16. We don't see any proton strikes. No coronal mass ejections have moved into the Earth-facing zone. We don't expect any proton strikes. We'll keep you posted if we do expect any. Proton events are super serious. Next, looking at the real-time solar wind to see this enhanced coronal hole solar wind stream here. It's been well over 600 kilometers a second, making it all the way up to about 680 kilometers a second here at the peak. Now slightly off of that, around 618 kilometers per second. Current solar wind density 9.02 protons per cubic centimeter. And those are primarily hydrogen nuclei, folks. So here you can see the geomagnetic storm conditions. We've been in a G1 class geomagnetic storm here for the past 9 hours approximately, having made it up to a KP of 6 over here on March 1st. So this coronal hole wind stream once again lasting much longer than expected. Again, seeing those elevated coronal hole wind protons there at 600 plus kilometers per second. Here's what's going on in the geospace, a visualization of 4 hours of the magnetosphere, and that increased pressure there shown in red is a result of those high-speed protons. So the density is at a pretty nominal level here, around 8 or 9 protons per cubic centimeter, but the speed is significantly higher than what we'd call background solar wind levels. And that's the reason for the increased pressure. Here are ground magnetic perturbations, and we're looking now at the Earth and changes in the Earth's B field, or delta B. So changes in the Earth's B field are kind of important during a geomagnetic excursion, and since we're living through one right now where the Earth has two north poles and a south pole that's migrated into the southern Indian Ocean, we show this data daily. What's in your daily space weather? Is it full of nonsense or is it full of facts? Leave us a comment below. So that's the view from the poles. Here's the global view. I'll bring that back. There's the global view. And these do coincide with auroras very often, most of the time. And we do expect to see some auroras there, perhaps in the northernmost states of the U.S., southern Canada, lots of Canada, actually. And you can see where the South Pole has left the Antarctic continent entirely there and is in the southern Indian Ocean, south of Australia. Here's the auroral forecast. This will show you the likely places where auroras are. Keep in mind it's just a model, folks. And we'll let that play through. If you've got photographs of auroras, or if you're in a location where you're likely to see auroras, go out and use a camera. Take a camera and take some time-lapse imagery or perhaps a video of the night sky to the north. You may see things that are not visible with the naked eye. Your camera is able to see a larger portion of the electromagnetic spectrum than your eyes are. So here's the GOES magnetometer over the past 3 days. And we see some fairly low readings actually there on the GOES magnetometer. There's still a bunch of plasma in between the Earth and the Sun. And those spiky readings are a result of that coronal hole wind stream. So here's another view of magnetism. This is the top view ecliptic plane field plot, part of the National Sunspot Observatory. This data is gathered from ground-based magnetometers on Earth, 51 of them, as well as ones at Lagrange point 5, stereo A, and Lagrange point 4, stereo B. Earth is in a North Pole-oriented current sheet, shown here in green. The South Pole-oriented current sheet, shown here in red. Let's continue on to show the Sun's B field, which has been seeing some changes here as the solar polar field reversal continues. This shows the solar magnetogram as well as the poloidal fields. The Sun's B field is those blue potential field surface source lines. And we see some migration of that as the solar cycle advances. Here's the line of sight coronal hole plot, and you can see that now Earth-facing North Pole-oriented coronal hole right here. And we can expect another coronal hole wind stream from that in about 2 days. The current solar wind stream enhancement is a result of this coronal hole right here. And coronal holes are super important in the realm of heliophysics. We're still planning a video about coronal holes. Don't worry, folks, we haven't forgotten. We've just run into all kinds of delays in making that video about coronal holes. So here is another magnetic diagram. This is the diagram of the Sun's atmosphere, known as the solar corona. It's quite a chaotic place. And speaking of chaotic places, let me check the life of the stream. And it looks just fine. And you can actually see the location of that North Pole-oriented coronal hole. You can see those black lines. Those are North Pole potential field surface source lines from that Earth-facing coronal hole. So an Earth-facing sunspot, a nearly Earth-facing sunspot, and an Earth-facing coronal hole right now. Lots of stuff going on. Here's a diagram of the atmosphere. So this is going to show you the penetration of electromagnetic radiation, which is this portion right here. It's going to show you things like temperatures at solar minimum and solar maximum. These things do change size when we see geomagnetic storms and stuff. Also, this right here, this is the F ionosphere layer. These are the layers, the D, the E, the F layer of the ionosphere. The F layer is where the GOES 16 makes its measurements. Here's another diagram showing you the Earth's Van Allen belts, the inner and outer Van Allen belt, as well as altitudes in miles. And moving into talking about electrons, we see some charging hazards. When you have a lot of electron flux out there in the Van Allen belts, we have a tendency to see charging hazards for satellites. And we do see some, and indeed we've just moved into electron flux warning levels. More on that momentarily. There are the charging hazards, mainly over the Caribbean and Central Pacific and Mexico and Central America. So here's the 3-day chart of the electron flux. And surprisingly, we've got into electron warning levels here despite the coronal hole wind stream. So lots of stuff going on, lots of matter out there. And what you're looking at here is electron density. So this is literally a count of the number of electrons out there, particles per cubic centimeter, centimeter to the -2 squared. And yeah, levels are currently rising as we make the video. And our patrons would already know about the electron flux warnings as we alert our patrons long before anybody else and long before we're able to make a video like this one. So here's a 1-year chart of the electron flux. These are the relativistic electrons we're talking about. The greater than 2 million volt electron fluence. So greater than 2 mega electron volts, 2 million volts. They're pretty fast moving electrons, let's just say, approaching the speed of light, back and forth around the Earth in the Van Allen belts. Here's the forecast, which is all over the place. And look at how far the forecast was from the actual observation yesterday, very far off, and quite far off the day before, and 2 days before that, quite far off as well. It's not easy to forecast the electron flux, and no comment on the electron flux forecast. The green boxes are the forecast and the yellow diamonds are the observation. NOAA forecasting an increase in the electron flux despite already be at warning levels. So we're actually already up here, folks. And yeah, I don't know. Just check it out. Check it out yourself. You can find links to all of this stuff on the Space Weather Enthusiast dashboard and so on. This is the relativistic electron forecast model. Here's a visualization of that. The total electron content forecast visualization. It's showing you essentially the electron density for the entire air column up to where your GPS satellite will be located. It's actually pretty organized here. And we typically see more organized electron clouds when we see high levels of electron flux than when we see low levels of electron flux. So surprisingly, very high levels of electron flux during a coronal hole wind stream. Here's the ionosphere map. It's just one slice of the atmosphere. So the previous one was the entire air column. This is just the ionosphere layer. So you're looking at the F layer there around 300 kilometers where the GOES 16 endeavors to make its measurements. That's a full day of data. And we're looking for anomalies here and so on in the ionosphere. Nothing too crazy going on there. Here's the latest image. It's from 10:30 Universal Time. And once again, around this time of day, we see a charge up the last 3 days over India and the Central Indian Ocean. Next, moving into the realm of meteorology. Something that when you understand the physics... Oh, and by the way, let me just take a quick moment to explain how we forecast coronal mass ejections. I know many of our viewers are interested in how we forecast coronal mass ejections, and I'm going to give one little tidbit, just one, about how we do it. The way I forecast coronal mass ejections, folks, is by understanding the physics. Moving on to meteorology, here are the jet streams of the eastern world. And we continue to see this powerful cyclonic system here in the southern Indian Ocean there off of the western coast of Australia. Jet streams a little more organized than we've been seeing in past days in the eastern world. Here are the jet streams of the western world, which are quite disorganized. Look at those S-shaped portions of the jet stream. And the jet streams would be the most significant weather snapshot you could take if you want to be a global meteorologist, a global weather forecaster. Next, looking at lightning. And we're at lightningmaps.org, my favorite real-time lightning map. And check it out. It looks like we may see some terrestrial lightning here over Florida, or perhaps in the Atlantic. And there we see some strikes out in the Atlantic Ocean Apparently no terrestrial lightning. Hey, Savannah and Jacksonville. Go outside and look to your east. You may see sprites, green elves, or other weird stuff above those thunderheads. Here's a pressure map. And we're doing the GFS forecast here. This is on windy.com. They've got a great mobile app you may want to download. We're not paid to say that, at least not yet. And here is the pressure forecast via the GFS model. So here's the current pressure environment, pressure cells. And here's where we expect things to be at 12 noon tomorrow Eastern Time. As we zoom in slightly farther here, here is what's going on in the cloud layer over the U.S. We use the shortwave radiation map. So the 3.9 nanometer radiation map will show you where clouds are located. When it's too dark to see them with the visible, you can find all of this at the NASA GOES interactive weather satellite. So there's the cloud situation. Here's the water vapor situation. And that atmospheric pond now moving into that atmospheric river, having become an atmospheric pond, just moving off of the coast now. So fantastic view of that in water vapor as well as in shortwave radiation. And yes, water puts out radiation, folks. It's just a fact. Here's the U.S. Doppler radar map. And we see some heavy snow there over northern New York, once again east of Ontario, and some ice storm there in central North Dakota. And for those southern states, I would expect those heavy rains to be moving off shortly. As you can see in the water vapor, this dry mass of air is going to give this a nudge out into the Atlantic Ocean. It shouldn't last all day. And thanks Smash team for tuning in. We've got bonus features. But first, we've got to thank our patrons, the true source of funding for the content. Please consider becoming a patron at patreon.com/smAsho if you want the earliest alerts. Alerts long before we put up a video on YouTube or Twitch or any place else. Thanks again, patrons. Again, our patrons are the true source of funding as we make just this side of nothing to put the videos on YouTube. So if you're viewing on YouTube and you can spare a few bucks per month and you'd like the earliest alerts in the world about this sort of stuff, patreon.com/smAsho. We need lots more funding to accomplish our goals once again in the year 2021, year of accountability. So please consider doing so. If not, just press like and subscribe, press the notification bell, and share the videos on your social media before we vanish entirely, as we have lots of incentive to make the videos no longer public and no longer visible to the general population. So press like and subscribe, share on your social media, increase the probability that these videos will continue to exist and be free to view. And thanks to our viewers, especially on YouTube, but also BitChute. Leave us a comment, etc. Here come bonus features in the form of the solar magnetogram and the intensitygram. So here's the latest state of affairs when it comes to Sunspot 2806 and 2807. There's 2806 and multiple groups of umbrae there. It is still a beta class sunspot. Here's 2807, slightly larger there in terms of individual umbrae, but less total. Total umbra space is probably pretty similar there in both groups. There's the zoom out of that. Here's the colorized magnetogram. We may have another group forming, sorry about that, not up there. We may have another group forming up here. So that's an area to keep an eye on. And when I say eye on, well, the pun is intentional. So here's the close-up of 2806. Here's a close-up of 2807, and you can see 2807 a little bit more powerful there, a little more organized, magnetically speaking. And we'll close things out with a couple close-ups of the southern hemisphere of the local yellow dwarf. And if you've got comments directly for the sun, leave them in our comments section. Perhaps we'll read them in a later daily space weather video. So there is the close-up of the southern hemisphere. Sunspot 2806, Sunspot 2807. We've got a couple more wavelengths for you here. Here's 131 angstroms. Give it a minute. There we go. We've also got 94 angstroms. And this should give you a great view of the solar flare, by the way. And you can see the majority of the flaring actually coming out of 2807 there. And by the way, the Earth-facing quiet effect, the reason we don't see solar flares as much from sunspots that are directly facing the Earth, supports theories of the sun proposed by Dr. Robitaille. So the theory of the sun being made out of liquid metallic hydrogen is actually supported by the, quote, Earth-facing quiet effect. More on that later. In fact, we should make an entire video just about the Earth-facing quiet effect to help to advance the science. Last but not least, here's 171 angstroms. The Earth-facing quiet effect, folks, it's not magic. It's not magic. It does not support the theory that the sun is conscious. It doesn't disprove the theory that the sun is conscious either. But the Earth-facing quiet effect is caused by what the sun is made of. So no more on that, as we want you to watch other videos on the channel. That's about it. I've been your host, Dan, a.k.a. smAsho. Thanks again for tuning in to the Daily Space Weather. Don't forget to press like and subscribe. Don't forget to share with your friends and foes. Don't forget to share with your science noobs and your science pros. Also do attempt to understand the physics. And when you're staring at the sun and understanding the physics, don't drink. But if you do, don't drive. And since it'll never be now again, may that solar wind be at your back.